Okay, this is a second set of energetics multiple choice questions, all past paper questions from old AQA A-level chemistry papers. So as I said on the previous video for energetics, these questions often take a little bit longer. It can often be a full calculation. So do pause on each question and do your best to work through it and see how you manage. Once you're done, you can unpause, you can review and see how you've done. Okay, let's start with question 1. And you can see here that we're working with bond enthalpies. So first thing that I'm going to recommend is that you look at which bonds are actually being broken. And we've got 4 CHs and 2 OHs. From there, we can take the data from the table and we can multiply up. It's positive because it's endothermic, because bond breaking is an endothermic process. And we can see that my total energy for bonds broken is 2578, or more specifically plus 2578. If I then do the same thing for the bonds formed, I've got one CO bond being formed, and that's going to be my X value because that's what I want to work out. But I've got 3 H2s. That's 3 negative 436s, taking us to negative 1308 plus X. Now, I also know that my total enthalpy change is 206 or plus 206. So I've substituted all of those into an energetics cycle. I've got my 2578 going up, my negative 1308 plus X coming down, and my 206, and I've got my 2 roots. So my 2 roots, following Hess's law, that the overall energy change is the same whichever root is taken, and I get this. I can then rearrange it to make X the subject, and then from there I can work out the value of X is 1064. Now you'll notice that it's calculated as negative 1064, but because it's a bond enthalpy, they're generally given as the endothermic breaking process. Next question. And on here, we are being given enthalpy of combustion data. Let's take a look at what we can do with it. Well, to begin with, we want to know how many moles of each of these things there are. So I'm going to start with ethine. I've got an MR of 26 and I've got 2 grams of it. That means that I have got 0.077 moles. Now from there, I know that I want to know where 2 grams will release exactly 100 kilojoules of heat energy. So if I were to do kilojoules is 100, moles is 0.077, rearrange that into kilojoules per mole, you can see that it comes to 1300. And that's precisely the value that we have in the table. Now I could go through B, C and D to prove that that won't bring you to the number for their enthalpy of combustion, but I'm not going to do that. I'm happy that we've got to the answer there. Next question. So my first thought here is that I've got a mass of propane. I can find the MR of that propane, and if I've got the mass and the MR, I can work out the number of moles, and I get to 0.0023. So that's how many moles. I know how many kilojoules there are, so my delta H is kilojoules per mole, 5 divided by 0.0023, which takes me to negative 2,200. Correct answer is C. Next question. So in this, I've been given enthalpy of formation data. I want to know what the enthalpy change is for the reaction in the equation at the top. So I'm going to build a cycle, and I'm going to put that cycle up on the top right-hand side. CO plus H2O goes to CO2 plus H2, and the value for that one is X. Now, because I've been given enthalpy of formation data, I can actually start to add in the remainder of the cycle. To make CO2 and H2, I need C, H2 and O2. My formation of carbon dioxide is negative 394. H2 formation is 0 by definition because I'm forming it from its element in its standard state at standard temperature and pressure. But I've also been given the enthalpy of formation of carbon monoxide and water, so we can put those in. There's 1 mole of each of them, so it is simply negative 110 plus negative 242, giving us negative 352. At this point, I'm going to identify what my 2 routes through the cycle are. Hess's law tells us that the overall energy change is the same whichever route is taken. So I'm going to take my blue route and my green route. Negative 352 plus x is negative 394. If I rearrange to make x the subject, that takes me to x is negative 42, and the answer is B.